Okay, welcome everybody to our introduction to machining and also what's new in Creo 9 when looking at the machining side. So first of all, I'm going to do a quick 2-minute introduction to Creo Machining and some of the challenges that we face in today's market. And then I'm going to hand over to my colleague, which will do a full technical demonstration. And afterwards, we will handle the Q&A. Before we get started, we will send you the recording of this video, and it will also be uploaded to our YouTube channel. Please ask your questions in the Q&A section at the top of the Teams meeting, and we will address all of that in the end. And then also we'll be asking you to participate in a poll when it's prompted. And please participate, and we value your opinion. So first of all, why Creo Machining? So we are going to look at the 4 most common challenges faced in today's world. First of all, need to improve your company's revenue and profits. So we all know that having multiple separate engineering tools disconnects and slow down engineering process, and using machining capabilities within your design package will overcome this pain. So to lower your total manufacturing cost, then competitive market and also winning new business. So we all know the market is just getting more and more competitive, and to land that new clients, you all have to compete against people that's doing and accessing the latest and greatest technologies. So companies that have efficient manufacturing processes that delivers fast but still have the best quality will turn out to be the winners in that situation. Then ensure the delivery of parts and tooling on time and under budget. So back to the first point in this one, of how a disconnected machining solution can cost you on efficiency and the loss of data and time. So eliminating the data translation can enable concurrent design and concurrent manufacturing. Lastly, we're going to look at the high cost to recreate and update in NC sequences when designs are modified. So because Creo Machining is part of your CAD design package, this process is automated and eliminates the concern entirely. Next, we're going to look at the extensions that is offered by Creo to tackle this. So Creo provides a comprehensive suite of manufacturing solutions. So whatever your requirements are, we can cater for that. First of all, we've got the Creo Prismatic and Milling Surface extension. This offers you 2-axis machining as well as 3-axis milling. And this extension is part standard of if you've got access to a Creo Design Advanced license. Then Creo Production Machining extension. This offers everything the Prismatic and Milling Surface extension does, plus 2 to 4-axis turning as well. Then lastly, we've got the Creo Complete Machining extension, which offers the complete 5-axis suite of tools. And then also we offer Creo High Speed Milling. So this is if speed is of the essence. Please look into this. So the first one is a 3-axis capabilities for roughing, rest roughing, finish, and rest finishing. And then also we've got the 5-axis version of that as well with the High Speed Milling Advanced. So my colleague will go into a full technical presentation afterwards. So I'm not going to go into technically what these extensions does, but that's a short overview. And then getting to today's presenter for the technical portion, we've got Reginald Ngelo. He is a mechanical engineering technologist, and he's got over 5 years of designing experience. He worked at the Institute for Advanced Tooling, so people might know it as the Stellenbosch Technology Center, as a machining technician, where he was programming and operating a Hemel 5-axis CNC machine. So he also does training for Creo and Arbitex, and is a senior application engineer at Product One. So I'm going to hand over to Reginald to take you further through the technical demonstration.
Thank you, Ernst, and good morning, everyone. So I'm going to be talking about the product development process. So typically when you've got a product development process, you start with a concept design. After a concept has been created or designed, and then you go to a detailed design where you are going to be creating the different parts assembly to get the design that you are looking for. After that is done, we typically go to drawings. And then after the drawings are done, we can go to simulation and lastly to machining. But in some cases, some of these processes could run parallel. So while the drawing could be done, in some cases, the machining could also start. So the question is, what are the challenges that are typically faced when you are with machining? So the current challenges that are mainly faced at the moment is that most companies, they are having 2 or more softwares that are used. So you'll find that they are using one software for doing the design, the other software for manufacturing. And the challenges with that is that sometimes the data can be lost because the data has to be translated from one software to the other. And most importantly is that you do not have the parametric association. So what happens along the way if it happens that a design changes? What do you do? Most of the time you'll find that a part must be exported again from the CAD software and re-imported again in the CAM software, which is a common challenge that companies are facing today. So how do we go around about solving some of these challenges that are being faced in industry today? So well, that is where Creo Machining comes in. So Creo Machining has a premium machining capabilities that allows programmers to create various toolpaths, verify jobs that they created, and output the machining codes for machining. So you can do toolpaths creation for CNC lathe, milling, wire cut, and CMM as well. So depending on the type of extension that you are buying, so it will give you the different options that you can be able to machine. So you can have the post-process creation for various toolpaths. So you can also tweak your post-processor to modify it as according to your requirement. So there are some 3-axis, 4-axis, and 5-axis capabilities as well within Creo. So what are the capabilities of Creo Machining? So you can create toolpaths from simple ones to complex one, depending on how complex your part is. There is the option for high-speed machining for quicker machining time. As my colleague mentioned, that there is an additional extension for high-speed machining. So you can be able to do milling, lathe, and multi-turn capabilities. So you've got more functions to make the creation of toolpath easier. So that means that your CAD interface or your general Creo or part modeling interface, some of those interfaces are now mainly available also in the machining side. So it makes it quite easier for you to understand or familiarize yourself with the machining side. So something that is also new is that you've got module works material removal simulation. So this has been introduced from Creo 4 onwards. Okay, so now you do not have to use VeriCAD software to do the materials removal simulation. The simulation now it's built in within Creo, so you can see how your material is being removed before you can output your G codes for your machine. So it is easier to create toolpath boundaries using core functionalities. As I've mentioned a bit earlier, that you can use your core functionalities such as creating your revolve, extrude, some of those user interfaces that are mainly common on the design side. They are also available within the CAD, within the machining side. So again, so if the other benefit is that if the Creo part changes, the machining part changes as well, updates as well. This is an important point because if it happens that there are some changes that are made along the way while you are still machining or while you're still creating a program, you'll understand that some parts are very complex. So creating the program can take a couple of hours. Sometimes it can take a couple of days, depending on the complexity of the part that has to be machined. So in some cases, this can take a lot of time. So if there are design changes, so that part changes as well, the one that is on the machining side. You've got the Creo UI in machining, as I've mentioned. So that means that now it's quite easier for you now to use the core functionality stuff that are on the Creo side, on the design side within the machining as well. I think something that is also good is that as they are in bringing or updating or bringing a new version of Creo and the machining side gets developed as well, most of the toolpaths have a dashboard. So it makes it easier for you to see things visually, so you don't have the menu manager. Yes, there are still some that do have the menu manager, but a majority of them at the moment, they've got a dashboard. Easier to make some changes also to your post processor if the need arises as well. Another part is that you can configure your machining setup with feeds and speed associated with the tools. So I can have a tool that I have created. That tool I associate my feeds and speeds on that tool and save that information on that tool. What is important is that now, after I have done that, next time when I'm creating a new toolpath using that very same tool, I can pull the information of my feeds and speed directly from the tool without me having to do that manually. And the other good part about it is that I can associate that information again with the different types of stock material. So it saves me time from always having to go back to the supplier of the tools to get the feeds and speed for various tools and material, so I can be able to pre-configure all of that. One of the benefits or the functionalities of Creo Machining is that creating toolpaths to creating templates to all toolpaths template to auto-populate toolpaths. So this one is a very good function that is within the Creo Machining. So if you look at the image on the this side, on the right-hand side, I can have maybe 3 or 4 toolpaths, depending on how many toolpaths I've created. I can save those toolpaths as a template. So after I have done that, next time when I'm creating a new job and I want to re-import those templates or those toolpaths, I can then go insert the step from templates, specify that XML file that I've saved, and then it will bring in all that information that I've saved previously. If it matched, it finds all the references, and then the toolpath will work. But sometimes it could be that, okay, now you have to just select a new references, but things such as your tool, things such as your feeds and speed, your step depth, your step overs, all that information is already there. So the benefit of this is that it helps you to be more productive. So you don't have to spend too much time recreating your toolpath. The software can help you to be more productive in terms of your toolpath creation. So what are the new things that are in Creo 9 machining? Okay, so there are some of these things that I'm going to mention. I'm going to be demonstrating some of them. So you can do sorting NC parameters, so you can be able to sort them according to name. Toolpath color setting. So this is a very good one. So I can specify my toolpath color settings in terms of my feeds. So for example, I can say, okay, my feed, maybe feed rate between 100 to 2,000 millimeters per minute, or I can say must have a certain color from 1,000 to 2,000. I say, okay, this one must be red, 3,000 to 5,000 is blue. So according to the way I've set my feeds, and then my toolpath, when it plays, it's going to be playing according to that color. You can be able to create some user-defined parameters in a sequence. So within the turning side, you can be able to, especially things such as your groove, you can be able to, there is the tangential and circular settings in turning. So you can also within the turning side, there is a split follow cut. That means that if I've got the cut that I've created for the turning, removing some material, I can split it within a specific area. So for example, if I've got a toolpath, the toolpath is going to be created or done in 5 minutes, or maybe let's say 10 minutes. I can split that toolpath based on a ratio. If I say 0.5, it's going to split that toolpath in half. So I can have that option as well. So for high-speed machining, high-speed machining has been introduced a few years ago. So on top of the current suite that is there on the machining. So that is if you want to be able to machine, especially if time is more important, you want to be able to create tool parts that whereby your parts could be machined within a short period of time. You can consider high-speed machining. But what is new is that within high-speed machining, there is adaptive feed as well, which is quite good because when you go to corners, maybe you want your tool part to the feed to be slower as it exits the corner, it increases. So that's an example of an adaptive feed. So on the high-speed side, there has been some constant loads improvement from Creo 6 until Creo 9 when you're manufacturing big models. So for example, your constant load and constant load parameter, there has been some improvement in terms of how many minutes it takes to actually machine your part. So here they're making an example of the improvements that are there. But again, this will vary from job to job and the shape of your component as well. The other one is associative in-process stock. I'm going to be showing towards the end a demonstration of this one. This is where I can associate the stock within my machining site, and every time I make a new tool part, I update that stock. Okay, so that's also a good one. Okay, so before we go to the demonstration, so this is the scenario. Okay, so I'm going to be manufacturing a manufacturing company. We're going to be machining complex parts. So this is one of the parts, the part that I'm going to be working with today. Okay, so this part is going to be manufactured using the 10 milling. Okay, and then we're going to be using different tool parts. So we're going to be combining some turning tool parts. We're going to be combining some of the high-speed machining tool parts, the normal convention, the normal one like your prismatic and multi-surface machining tool parts and so on. So we're going to use a mixture of tool parts to be able to machine this part. Okay, and then if there are some changes that are required, and then we'll just update the part. So for example, after some tool parts they're created, and then you find that the part changes, and then we're just going to look at how that is done. Okay. So let me go straight to the demonstration. So I'm going to open a part that we're going to be working with. So I'm going to be working with this part. So this is the part that we are interested in using. We want to create some manufacturing model for it. So I'm going to create that. I'll just call it machining. Give it the template that I want to use. Before we do that, the first thing that we're interested in is that we want to add the fixture. But you will see just before I start with what I have to do today. So you will see here, this is the ribbon. So we mainly work from the left to the right. Some of the things that you are familiar with, your points, coordinate system, your sketches are here. And then let's have a look. So let's start with a fixture. We want to import a, let's check you are having a fixture that you want to actually use. So Let's have a look. So we're going to be using that fixture. And you can see these are some of the tools that you use within assembly. I'm going to assemble this as default. Okay, so that's the fixture that we are having. Now we are interested in creating or importing that model that we're talking about. Okay, so we're going to be opening this model. Let's assemble that model. So similarly, the way you will typically assemble a component, we want to make that to be coincident. We want to give it some space between the chuck and the model. So we can always give it some space so that we can allow our stock to take some, so for us to have the stock that we want. Okay, so now after we have done that, the next thing that we want is that we want to create maybe our coordinate system that we're going to be using for this demonstration. So I can use my planes, just open the planes temporarily. And then we are going to use maybe these two planes to create a coordinate system. And we want to create the coordinate system there. So that is where we want it. So we're going to call this coordinate system M0. Okay. Now I'm going to disable all the coordinate system because I no longer need them. So we've got our fixture and then we've got our component. Now we want the workpiece, and by default it is rectangular, but this shape is a cylindrical part. We're going to make it to be cylindrical. I can extend it to the back side because let's say that is where it's going to be clamped. So you can see there is a gap between the jaws there, so I can always go to options, specify, for example, if I know the diameter of my stock, have it accordingly. Okay, so now there we've got our workpiece. As we've got our workpiece, you can see everything is starting to take shape. Now, it could happen that in your company, you might be having various machines that you are having. So you can then come here and create a work center for all your different machines. So here, we're going to be looking at a mill 10. And the mill 10, you can give it the name of the machine that you're going to be using. And then this time, we're going to be focusing mainly on the 5-axis. Okay, so we are specifying that we've got one head. Okay, so we are not going to use more heads than one. So after we've done that, we specify our operation, specify our home zero position, and then we just enable the fixture that we are having. Okay, so you can see I have already set up all of this information. What is important or worth noting is that it's not always the case that you can or you have to do this manually. So it's not something that you have to do all the time. So you can do this and then save this manufacturing model for later use. So you don't always have to do this all the time to set up your tool. So saving that manufacturing model will save you some time because this will help you in terms of having predefined machines. Let's have a look at creating a mill window as a start. So a mill window, it's like a boundary that I'm going to be using to specify to my tool that, okay, this is the area where you are supposed to be machining. So I can specify my mill window. So I can do things such as sketch, specify that I want to sketch there, create my sketch. As you can see, as I've mentioned, that some of these tools are the ones that you are familiar with. Like you can see, this is our sketching ribbon. So I'm going to create a circle that gives me the boundary that we'll use during the course of as we're creating some programs. I can specify it also from to what reference do I want this mill window to go to. So that means that I might want a tool that will cut from here until to that specified reference. So there are other ways that I can also create my mill window. I could use things such as chain as well. Okay, so we've got our mill window then. Okay, so everything is taking shape. That means that now we are almost ready to create our turning or our toolpath. Okay. So the other things that we're going to be looking at is that we're going to be looking at the toolpath. So for example, I can have my cutting tools. Within my cutting tools, I can create some of the cutting tools. So you will see as I'm going further that some of these cutting tools, I'm going to open one of them that has been already predefined. So you can create your own maybe cutting tools on Creo, assemble it, and then bring it within the machining side. So let's have a look. Firstly, let's do some turning, and then after we'll do some maybe turning toolpath, and then we'll just simulate it and see how it looks, and then we'll dive deeper and look at the milling side. So one thing worth noting is that after I've created the operation, you can see now there are new 2 tabs that are added because of a mill turn that we're using. We are interested in using the turning. So the first thing we're going to do is that we're going to do a turning profile. We're going to be using a coordinate system. Okay, so you'll see the software is intelligent enough to understand your outline of your shape. And with that shape that you are having, you can be able to actually just drag to specify, okay, where do you want your shape to start? Where do you want it to end? What about a situation whereby you are realizing that there could be a collision within this? So you can always go to your profile, add a new one, and can I say, okay, so I just want to modify how this profile looks like, as you can see here, just to maybe avoid some collision there. Okay, now that we have done the profile, I can easily, then I'll just do an area turning. As I give it an area turning, there is no tool currently, so we can maybe use one of the tools, the turning tools. It gives us the default one. I can change the values accordingly. And then you can see I can specify my different cut speed, my type of scan that I wanted to rough and so on. If I maybe want to leave my rough stock allowance accordingly. So you can see it has already created the toolpath for me. So now we can say, okay, here there is a problem here. It's going further than we wanted to. So I can always come here, just come here and then just limit it so that it doesn't go further than where it is. And these are the options for the new one for the lead out, the tangential, exit, and circular. So as you know, typically you could do your general simulation like this one, and then it will simulate your material in here as you see it, but there has been the material removal simulation as well, which is the one that I'm going to be showing now. So as we do the material removal simulation, you will see the stock will be shown and the fixture will be shown. I can then play the toolpath. This time around, I just want to not to show the toolpath. Okay, so, and then depending on the speed, and then I can be able to show how the material is being removed. Okay, so I can see physically how my material is being removed, and that also gives me an idea of whether it's going, this part component is going to be machined the way I want it to or not. So there are quite a few other stuff that one can be able to look at. You can look at things such as creating your sections accordingly. You can specify your precision, and then you can also specify whether do you want your toolpath to be according to regular, a sequence, or according to a tool. Okay, now we are done with this one. So we've done the turning side. Okay, let's close that and save the work that we've done. Okay, so let's have a look on the milling side. We're going to be covering some few things. We're going to be spending most of the time on the milling side, and I'll show you some of the new things that are available in Creo 9. First thing worth noting that I want to mention that is new. If you go to machining tool setup, so you've got feed colors. Okay, so depending on your tool path, you can see here, these are the feed colors. You can see if it's less than 500, that's the color. If it's between 508 to 1016, so on and so forth. So you can be able to do that. The second thing, I think that also that is worth mentioning is that you can be able to sort out your tool path parameters. As you can see here, I can be able to sort them out. Okay, so that's some of the things that are new in Creo 9. But as we are going further, we're going to be diving deeper and talking about the others as well. Okay, so before I do, before I continue, I've done a mill window here. I'm also interested in doing a mill volume. So we're going to be using that for one of the toolpaths. So I can do a mill volume. So I specify my mill volume. Here I want to create a revolve. I can specify maybe one of the planes that I'm going to be using. And I want to maybe create a revolve, a revolve around this side. Okay, and then we want it to just revolve all around. Okay, so this is what we are interested in doing. Okay, so so this looks good. Just want to edit the shape, make it just slightly smaller, maybe 13. Okay, now that we've done that, what you can do with the mill volume, I can be able to trim it. I want to trim it according to that component. You can see it trims everything that I do not need. It only leaves those that I need. So that is also a good tool. That means that when you're doing some milling side on the volume, you can trim accordingly. Okay, so we have done that. Can just save it. And then now we can go to milling side. Okay, so within the milling side, so you've got your milling group. So this is the one where you can do your prismatic, multi-surface machining, production machining, and complete machining for 5 axis, depending on the license that you want. If you opt to go for the high-speed machining, so this is the group for the high-speed machining, and it has got a few of the other toolpaths, such as your trajectory, but not all of them. Both come standard with your hole making cycles, so I can do my spot drilling, I can do my packing. Accordingly, I can be able to do maybe all of those. Okay. So now what we're going to be doing here is that we're going to be doing some few toolpaths. Some of them are just normal 3 axis. Some of them are 5 axis. And then as we go further, and then we'll talk about other things as well. All right, so the first thing I want to do is maybe I want to rough out this. So I can maybe do my normal roughing. I can specify my mill window. Within my mill window, I can add a tool. So maybe I'm adding one of the tools that I've created within 3D. Okay, so I'm gonna look at let's have a look at my solid tools. So I'm looking for this tool. Maybe I've created a tool and then I specify maybe the tool that I'm looking for. So what you can do is that you can come to within your cut data, specify what type of feed or speeds you're going to be having, what type of feed are you having, and then that information can be saved on that particular part, such that this information can then be reused, as I've mentioned, when you're creating your parameters. So, and then from here, I can specify my clearance. Okay, and then here you can always go to your parameters and then change the information accordingly. So you can see that I've stored some information on the toolpath, on the tool. I can go to the parameter. Within the parameter, I can then be able to import all the information. You can see my spindle has updated and my feed as well, because this info and the cut fit, because this information was coming from the tool. So this is a benefit of saving the information on the tools. And then we can create maybe the tool path, and then we can see exactly where it is going to be roughing. Okay. So you can see there is the tool, and then it's going to be roughing according or within that boundary that we have given it accordingly. Okay, now, after we've done that, there are some new things that have been added on Creo 5, on Creo 9. So there is the geodesic one option, but before we do that, I just wanted to show you that you can also do things such as a volume rough. So I'm just going to be selecting one of the volumes there, and then I can be able to do some roughing then. Okay, so now that I have done that, I'm going to, let's just hide this information here. So what happens if maybe I want to do some finishing then? So since we've enabled the 5-axis capabilities, so now we can be able to do some 5-axis machining. So this is one of the new things or tools that are there. So you've got your geodesic finishing and also maybe your roughing as well. So for example, let's just have a look at geodesic finishing. I'm going to create just a normal tool, maybe our ball nose. We're going to call it maybe ball nose 12. Okay, so this is the one we're going to be using. And then we want to just machine it on that reference there. And then we're going to look at the tool path. Okay, so the tool path will be machining here, this side, and then we can create a pattern to machining it on several sides. So let's have a look. Let's just give it some few seconds as it is calculating. Okay, and then after this one is done, we're going to also look at some other options for drilling. Then we're going to be doing some strategies around to cut this part, and then we're going to update this part and see what happens. So there you can see I've got my finishing there on the side. You can see there is my finishing on the side. Okay, remember when I told you about those different parameters, depending on your feed, you can see this toolpath color also changed accordingly. Okay, so what one can do now is that after that is done, I can select that option and use some of the tools that I have used in Creo. I can use pattern, for example, pattern that. I'm going to pattern that as an axis. Maybe select one of the axes. We're going to make it to be 3. And then we're going to be pattern it around 360. So now, what are the benefit of what I've done now is, if I've patterned it here or I've created that sequence to cut this side, and then now, instead of me having to select all the other surfaces, I can just pattern it, and then it will create the tool paths for the other side. So you will see now that I've got the different tool paths there. So one of the other things you can do, because we've enabled the 5-axis capabilities, the software is intelligent enough to understand that you've got your different holes within the component. So let's take, I want to do packing. Yes, it's important to first do spot drilling, but in this case, I'm going to be looking at packing. I do know that I've got some components here that are 11 diameter. So let's have a look into creating some holes. So I'm going to create some pack drilling. So with that, I'm going to create a new toolpath because we're going to be drilling. So we're going to be drilling, and then our diameter is going to be 12. So I'll call it maybe 12 drill as an example. Okay, so that is the drill that we want to use. Okay, so what you can do is that you've got your different holes that are available that I can select from using different methods. So here you can see I've enabled the 5-axis capabilities. So look at the details. I'm interested in this time around to look at maybe my 16 holes. You can see there are the 16 hole, diameter 12 holes. There are others as well. Okay, and then while I have this, so the software and then will allow me to, and then it will drill those different holes accordingly. So that is what you are having. So if I play those toolpath, you will see that it will be able to drill those different holes accordingly. Okay, so let's have a look at other toolpath options. So let's have a look at some other toolpath options. Okay, so just I wanted to go back to mention something also on the area turning that is new on Creo 9. So if I've got that cut there that I've created for my turning, I can go to my tool motion, select my tool, right click, and then I can be able to split it. As I've mentioned, I've split it by a ratio, for example, of 0.5, and then those are the different things that I can be able to do to actually split it according to that ratio there. So that is what I was talking about there. Okay, so now, so as I've mentioned that within the high-speed machining as well, you've got your adaptive feed rate, so you can be able to do adaptive feed rate as well. Okay. So the next one that we're going to be looking at is that I can also create toolpath, maybe for example in this area, maybe I want to do some 5-axis stuff. I can use the trajectory and then specify the toolpath that I want to use. This time around, we want to create the toolpath on this, maybe that curve there. So this is the one we are interested in. But we want it to start from here to the other side. So at the moment, it is 3 axis. I can easily change it to maybe to be normal to a surface, normal to that surface as well. So that is the one that we want to make it to be normal to. So, and then we can select where does it start. Like we can say it starts here. And then we can always select the height. Let's say we want it to end on a particular plane this side. So within the context of this trajectory toolpath, I can be able to create a plane there. That this is where we want it to end. Okay. So those are the different things that we want to use. So you can see that it's starting this side because of my clearance that I'm having. So to sort that problem, I can always go to a clearance. I say, okay, let's make this to be a cylinder. I'm going to use my coordinate system that we've created and give the clearance accordingly. And then as the diameter of it. Okay. Now you can see that it actually creates the toolpaths around that. If I go to my parameters, I can go to further just to make some changes within my feeds and my options for my parameters. So I want to show all of them. And then we're interested in the, just have a look, number, yes, this one. So maybe I want to have number of passes 5, the increment to be 3 so that it goes to the other side then. Okay, so this is mainly control depending on your different feeds and speed, your step depth. You can be able to control how it goes. So okay, so here, as you can see, if I click play, I can be able to play it. So it goes around, making it to be a 5-axis. Okay, so now we are towards the end of the demonstration. There are some few things I'm going to show. So let's have a look at a situation where I'm creating a toolpath. So this is one of the toolpaths, as I've mentioned, that I'm going to show that are available in the high-speed machining. So we want to machine these other sides. So I'm going to create this toolpath, which is called, let me see. So, okay, so we're going to be doing the roughing, so which is the one that we're actually looking for. Okay, so this is the one we want. So we want to machine this surface, okay, this other side of the surface, but we want it to be machined accordingly, maybe from that side there going down. Then I can be able to preview my toolpath. Okay, you will see now that the toolpath will be showing you the different areas. As you can see, it will be cutting all around and so on. So you can always go to your parameters, as I've mentioned, also to change your different cutting motions. Okay, so climb, you want it to be a constant load. What are the cut types? You know, so all of this. Do you want it to cut by regions or do you want it to cut by levels? You've got those options there. So you can see there is a toolpath accordingly, and then I click OK. Now, what happens if this part changes or updates accordingly? So let's have a look at this part. So I'm going to open it. So we're going to be changing or just updating the pattern as an example. Again, there are other things that can change accordingly as well. So I can, if I edit the definition, maybe I make that to be 6. Okay, maybe change it to 6. Okay, you can see now it has actually changed. So the shape has changed. Because this part is associated with the other one, that is within my manufacturing model. So I'm expecting that when I go to my manufacturing model, it also changes or updates accordingly. So let's have a look. So if I go here, okay, so I'll just need to update that to regenerate, just to update. Let's have a look, edit the definition. Okay, just quickly updating that flow. Then everything should update accordingly. So if I edit the definition, I show my toolpath, and then I'm expecting my toolpath to also update accordingly as an example. So I don't have to recreate it. Something also that is worth mentioning that it's going to be beneficial for you on the Creo Machining side. If you go to the manufacturing tab and then you go to the process manager. So here I've got my different toolpaths that are created. So for example, I can, if for example, I select that one, the different toolpaths that are created, I can take, for example, some of these toolpaths, maybe select that one, and then save this as a template. So I can be able to save this as a template as well, that I can be able to use it. But this time around, let's just have a look at a simple example. Maybe if that template was saved, I can go to my operation and then I can say insert step, and then I say from a template. So maybe there was another template that I saved previously. This template could be having different toolpaths that I've created earlier. And those different toolpaths, then I don't want to recreate all of them. I want to reuse some of this information that was on those toolpaths. Okay, so you can see here, I've got the toolpaths they are showing. I've got 1 and 2, but you find that here, okay, maybe it's missing a surface. So I can always right-click that toolpath, right-click, edit the definition. Okay, so all the other information is still here. The only thing that is missing, maybe it could be that it's missing the surface, because now I'm using a different surface and so on. So I just come, maybe I specify the surface that I want to select, and then from there, I can then be able to select, for example, a different reference that I want to use there. Okay. So, and accordingly. And then from there, again, you can be able to create your different toolpaths there accordingly. Okay, so that is that. And then again, after you find your after you've everything is looking fine, so and then everything can work. So for example, in this case, I'll just close here. Let's have a look if I can create something like a coordinate system. Let's have a look there, and let's have a look at. Okay, so what I wanted to do is that to show you that if you've got, for example, a surface, another different toolpaths that you've created, you can be able to reuse it. So again, within the process manager, I can go to the another one, right click, edit the definition, specify my reference, specify for example, where is going to be my clearance, and then based on that, the toolpath will update accordingly. Okay, now I'm going to show you what is new on the in-process stock. So there is another assembly that I've created, a machining model that I'm going to be using. So let's have a look at this one. So this is just a basic model that I've created. I'm going to be demonstrating this one. So you can see here I've got roughing that I'm creating. So I'm roughing this. And then after I am roughing this, and then I can come here, edit the definition, and then I can also do my rest roughing. But let's have a look. So what I can do here is that I can select my roughing, right click, and then I'm going to select stock model, roughing, and then I'm going to select my workpiece, and then I click OK. So when I come to my stock model, firstly, I'm going to just update the stock model, update stock model. So give it some few seconds, and then I'm going to activate the stock model. So you can see that now I'm working with my stock model. What happens if I want to create a stock model for the rest rough? I'm going to select rest rough and then create also a stock model. Again, I'm going to let's reference the workpiece. Okay, and then from there we update it. Okay, and then after we update it, we activate it. Just have a look at what's going to happen. You can see here that I've taken just the big chunks of step depths, and then if I activate that one, okay, depending on it is okay, because and then there is the other one that is removed. So I can from there, and then I can come here, edit the definition. Maybe I've got the rest rough. I want to maybe also use the in-process stock model to be able to create, for example, my rest roughing toolpath. Okay, so and then I can come here, stock model, right click, update that accordingly. And then, yeah, and then you can see now it has updated accordingly. Again, when you go and activate that other one, you'll see how it looks. And if I go to these other ones, this is also how it looks. Okay, so that is the end of the demonstration. Just to summarize the things that we've talked about before I end the demonstration, is that the summary is that within Creo Machining caters for all your CNC machining needs. Different toolpaths, there are many different toolpaths that you can choose from. And then it is integrated with Creo modeling. You'll see that when I make some changes on the Creo modeling, it also updates on the machining side. And you've got an easy to understand user interface. Thank you very much for your time.